Assalamualaikum all of you. Welcome to one more session for the hardware. In the last class, we just discussed about the types of the memory and we discussed about the RAM over there. That was a part of the primary memory. We discussed over there that's a volatile in nature, that means temporary, and anything that you are going to store over there will be lost as soon as you are going to shut down the power. Now we're coming to the next topic for the primary memory, or the next phase you may say, that is regarding a ROM. So now when it comes to the ROM, so ROM is actually a read-only memory and it's a non-volatile in nature. Now what do you mean with non-volatile? Non-volatile actually refer to as that it is permanent in nature. That means whatever you're going to store in the ROM, that will stay in the ROM until unless you're not going to delete that manually. It won't be deleted as soon as you're going to shut down the power. That is the reason that within the ROM there is a program, or you may say the boot up section. Boot up section means the startup section of your system is stored within the ROM. That's the reason that the boot up section or the startup section of your system is stored within the ROM, so that anything, or you may say we are not going to store that into the RAM, because if you are going to store that into the RAM, so as soon as you are going to shut down the power, so boot up section will also be deleted. That's the reason we are storing that into the ROM, because ROM is permanent as we just discussed. That is the reason we are placing it into the ROM. Now when it comes to the types of the ROM, so we do have three types of the ROM. That's a PROM, EPROM and a double EPROM. PROM, EPROM and a double EPROM. It's not in the course outline the details about the PROM, EPROM and double EPROM. So PROM, EPROM and double EPROM, the difference is that PROM can only be programmed once, whereas when it comes to the EPROM, it can be programmed multiple times, but it do require an ultraviolet light to be reprogrammed. Whereas when it comes to the double EPROM, so that is actually we are utilizing in our systems as well. So double EPROMs can be, or you may say are reprogrammed multiple times, but by the help of the certain softwares. Now coming towards the differentiate between a RAM and a ROM. Okay, now these are the 3 points and they are crucial points. Why they are the crucial points? They are crucial according to the examination point of the view. Now why according to the examination point of the view? The reason is examiner do ask multiple times, state the features of the RAM, state the features of the ROM. What's the difference between the RAM, what's the difference between the ROM. So when it comes to the features of the RAM and ROM, you may go ahead with this. When it comes to the differentiate between the RAM and ROM, you can go ahead with this part, so that will be quite beneficial for you. Now the first thing they are saying for the RAM, it's a temporary memory device, whereas ROM is a permanent memory device, as we just discussed. Can be written to and read from the RAM. You can just write something over there as well and you can read it from. Now read means that it's already stored over there, you are just going to open up that thing. Write means you're going to store anything over the RAM. But from the ROM, you have once wrote over there. Now data can only be read from, but it cannot be altered at it is a permanent sort of a memory. Now RAM, as we discussed, that it's a type of the memory that is storing the part of the memory or the part of the instruction that is currently being used. Whereas when it comes to ROM, so ROM is actually utilized to store the BIOS, that's a basic input output system, or you may say the boot up section or the startup section of a system. So that was for the ROM. Now coming towards the registers, so similarly, just like the RAM, registers are also volatile in nature. Now volatile means, as we just discussed, they are temporary in nature. Now register is something like, if I just draw a rough diagram that how to understand this stuff. So just assume, okay, now that's the symbol for the micro. So that's a microprocessor over here. Now just nearest to the microprocessor we do have a cache. We discussed in the last session. Just after the cache we do have RAM. Sorry, not RAM, my bad. We do have registers, then we do have a RAM, and then we do have a secondary storage devices. So we do have in this format. It's a cache first of all, that's nearest, then we do have registers. So now we will be discussing about the registers over here. So as registers are just like RAM, they are storing the data. That means a small amount of the data that is currently being processed. So a small part of that particular data is stored by a register. Now when it comes to the register, so in basic there are 14 types of the register, because multiple, why I'm utilizing the word basic over here, because multiple of the registers can be divided into further categories. Now these registers, why we are learning these registers right now, we can go ahead with the definition only. No, these registers will be utilized when we will be doing with the von Neumann architecture. Over there we will be learning that how we need to apply these registers in a von Neumann architecture or a computer or a modern day computer architecture. Now when it comes to the types of the registers, so we do have multiple type of them. We do have a general purpose register, we do have an accumulator register, we do have MAR, we do have MDR, we do have CIR, we do have input output registers, we do have the status register. You may see that status is further divided into the zero flag, carry flag, sign flag, and the parity flags. Now coming towards the general purpose. Now general purpose is actually working as a waiting area. Now what do I mean by that? Waiting area is something, for example, once the data has been processed, now it needs a particular device to be translated from one part to another part. Now what is that device or what is that path? That path or that device is actually known as a bus. We will be learning about them, the buses in detail after this. But now coming towards back towards general purpose. So if the bus is not available right now, so the data needs to be hold on at a particular place. So that particular place is known as a general purpose register. It is a waiting area. Similarly, if it needs to be processed by the microprocessor, so before the processing of the microprocessor, if the microprocessor is not vacant right now, so the data needs to stay at a particular place. That place is known as a general purpose register, and as soon as the processor is going to be empty, the data is going to come to the processor so that it could be processed now. Coming towards the accumulator register. Accumulator register is actually responsible to perform all the arithmetic and logical operations. Now what do you mean with arithmetic? Arithmetic operations control with the plus, or sorry, not control, it contains with the plus, minus, multiply, divide, modulus. And coming towards the logical operations, so it says equals to, not equals to, less than, greater than, less than equal to, greater than equal to. So these are the operations that accumulator is officially performing. Then we do have an MAR. So MAR actually holds the address of the memory location. As we all know that in the system, computer memory is divided into categories, or you may say into small sections, and each section is having a particular unique ID number. So MAR is actually, that's a memory address register that is actually holding that you may say section number or the address from where you need to bring the data or where you need to store that particular data after execution. So that address or the location or the address of that particular location where you are going to store that data, or where you are bringing, or from where you are bringing that data, that is stored into the MAR. So the address MAR is actually holding the address. Now when it comes to the MDR, so MDR, memory data register, or sometimes you may see it as a memory buffer register as well. So that it holds the data whose address was in MAR, whose address is present in MAR. The content of that particular location will be stored into the MDR. That's a memory data register, or sometimes you may call it as the memory buffer register as well. Then comes with the program count. Now program counter is actually holding the address. Okay, now MAR was actually holding the address as well, and program counter is, so you are saying that program counter is holding the address as well. Yeah, both of them are holding the address, but there is a minor difference. For example, right now we are working on the segment number 347 that is in MAR. Just after this is the address. Okay, now just after that, for example, we need to work on 359. That's an address once again. So program counter will be holding the address of the very next instruction. The instruction that you are processing right now, just after this particular instruction whatever the instruction you need to process, so the address of that particular location will be stored into the program counter. Coming towards the CIR, that's a current instruction register. This this register actually holds the instruction that what you need to apply over the data. This holds the instructions what you actually need to apply over the data that is present into the MDR. Status register informs you about the current status of your data, and it utilizes few of the flag registers to do so. Now, what are those flag registers? Zero flag. You are performing any sort of the task, that might be the comparison, that might be the plus or multiply or divide or any sort of the arithmetic operation, and you are getting a zero. So this zero flag will actually represent if it is on. Now how it is on? It is on by a 1. So if the zero flag is 1, the bit is 1, that means it's on, and if it's a 0, that means it's a off, that means you're not getting 0 as an answer. Carry flag, we discussed about the carry in the previous data representation. You can have a look onto that video. I think so that was video number 3 for the data representation. Please have a look over there as well for the carry. So if there is some sort of the carry while you are performing a particular calculation, so that will be represented by a carry flag. Sign flag, in similar video we did about the complements as well in the data representation. So sign flag, if the data is negative or positive, so sign flag will be representing that negative or positive sort of the data. And then it comes to the parity flag. If you do have an odd parity or an even parity that we discussed in the data transmission, I think so that was the 4th or the 5th video for that, when we were discussing about the error checking methods. So if there is a parity or an odd or an even parity, so that will be represented by a parity flag register. So that was all for the primary storage devices. Now just after that we will be coming towards the secondary storage devices. That what are the secondary storage devices? We just discussed that. We will be discussing about the categories of the secondary storage devices, HDD and SSD. So meet you in the next session. Thank you so much guys. Allah Hafiz.